MILCOM 2021. In here we present a paper Let'sTrace. Let'sTrace is a blockchain federated learning and tough In-ToTo enable cyber supply chain provenance platform. These are the authors of this work: Eranga Bandara, Abdul Rahman, Sachin Shetty, Ravi Mukkamala. First of all, I will give a bit introduction about me. I am Eranga Bandara, working as a senior research scientist at VMAS, Virginia, US. I involved with various research on blockchain, distributed systems, cybersecurity, machine learning, federated machine learning areas. One of our main motivation of doing research is we always try to do research and apply this research into live or real world applications. Let'sTrace is a one such platform that we have built based on our research. I'm available on Twitter. This is my Twitter username. If want, we can contact via Twitter as well. Okay, let's look at some background information first. Main information about software supply chain or SSC. SSC mainly involve compiling, integrating, and testing software from external sources into a completed software products. Normally, what we do is we take various software libraries or any third-party software components, integrate them, and build our software products. So that's the nature of the software development process. Due to this reason, SSC security is vital to enterprise software builds and should prevent attacks on SSC build systems. Since there are third-party software libraries and component exist, there are various attacks could happen in the SSC build systems. For example, attackers may try to inject malware through backdoors or vulnerability of the software build system. SSC security should prevent such attacks. So when using external software component, attacker may try to inject some vulnerability software component on there and do an attack. So this kind of attacks need to be prevented in the SSC security. In this paper, we proposed an approach to preventive security of SSC against the possible attacks. We mainly focused on implementing strategies for detecting and mitigating of the SSC attacks. This paper proposed framework called Let'sTrace. Let'sTrace we proposed as a blockchain integrated tough In-ToTo framework that enable cyber software supply chain provenance. Mainly there are three types of entities: software vendors who provide the software products, customers who are using the software products, and the service provider who hosts the Let'sTrace platform. These all parties collaborate in a blockchain network. Blockchain node can be deployed in each entities. Let'sTrace platform stores software update and supply chain provenance or metadata information on blockchain-based distributed storage. The tough and In-ToTo framework, so that's a core part of the Let'sTrace. Tough framework or the update framework and In-ToTo framework are integrated into blockchain smart contract to facilitate the software update and supply chain verification. Tough framework, the updated frame is used to as a secure software update system. All the software updates can be verified via Tough. The software supply chain information, all the software components need to be compatible with Tough and In-ToTo. In In-ToTo, all the software build related information, compile related information, all the supply chain information need to embed as an In-ToTo metadata files. So when software is compatible with In-ToTo, we can verify the supply chain information via using In-ToTo framework. Further, we propose federated learning enabled system. The federated learning system in Let'sTrace can build machine learning models with the supply chain data in different blockchain peers in privacy-preserved manner. So we use federated learning approach to build machine learning models. Different parties in the entities in the system can build their own machine learning models or local models with their own local data without exposing them to any third party. So these machine learning models further can be aggregated into a global model or average into the global model by using federated learning approach. We build a blockchain-enabled federated learning mechanism on top of Let'sTrace. Once machine learning models are built, these machine learning models can be integrated into blockchain smart contract to further analyze the software updates and real-time supply chain data. These are our main contributions. We propose blockchain-enabled cyber software supply chain Provenance platform. Use blockchain to store software update information, supply chain provenance information, and supply chain metadata information. Tough and In-ToTo framework integrated into blockchain smart contract to facilitate the software update verification and supply chain verification. Software supply chain verification, that means all the software components need to be compatible with Tough and In-ToTo protocols. Further, we provide blockchain-enabled web application to the entities in the system. So by using this web application, they can verify and view and verify the supply chain provenance information stored on the blockchain. We proposed a mechanism to analyze the service supply chain information on different parties or peers using blockchain-enabled coordinationless federated learning systems. With this system, peers can build machine learning models with the data on their local storage. Data could be supply chain data or maybe supply chain attack data. So once these machine learning models are built, these models can be averaged into global model by using coordinatorless federated learning system on top of Let'sTrace platform. So this is the architecture of this Let'sTrace. So we build it as a layered system. There are 5 main layers: stakeholder layer, smart contracts layer, blockchain storage layer, tough In-ToTo verification layer, and data analytics layer. Stakeholder layer, there are 3 main stakeholders in the system: vendors, service providers, and the company. Vendors basically provide software products. Companies purchase these software products and use them, and service provider hosts the Let'sTrace platform. The blockchain node can be deployed among each and every node entity in the system. That means all vendors, companies, and service provider have their own blockchain node. Smart contract layer, all the functionalities of the Let'sTrace we implemented on top of smart contract. There are 4 main smart contract in the system: identity contract, verification contract, agreement contract, and notification contract. When in here, we use self-sovereign identity-based approach to handle the identities of the vendors and companies. That means self-sovereign identity related DID, decentralized identity, will be generated for each vendors and companies. These identities will be stored on the blockchain ledger as a DID proofs. We handle this all the identity generating and verifying functions using identity contract. Then verification contract, all the supply chain update information and the all the software update information and the supply chain information will be verified by using the verification contract. For the software update verification, we use tough framework, and for the supply chain verification of the software, we use In-ToTo framework. Then agreement contract, when company purchases a product of a software product of the vendor, the agreement will be formed. This agreement terms will be defined, uh, various agreement criteria. For example, could be some term. If there's a new software update available, that update information need to be notified to the companies who are using this product. Other agreement term could be if there's any vulnerability identified by the vendor of the product, that vulnerability need to be notified to all the companies who are using this product. This kind of agreements can be encoded into the blockchain smart contract. The notification contract, so based on the agreement, there will be peer-to-peer notifications. For example, if vulnerability identified, that vulnerability need to be notified to the companies. In this case, vendor generate peer-to-peer notification to the company who are using these products. The notification contract handles these notification functions. The blockchain storage layer is the third layer. So we store all the identities of the entities, supply chain information, supply chain provenance information, and metadata information on the blockchain storage. Tough In-ToTo verification layer, all the software update verification and supply chain verification handled with this layer. Each and every blockchain node comes with their own verification service with Tough and In-ToTo. The fifth layer is data analytics layer. Each and every blockchain node linked with their own data analytic or federated learning service. The main purpose of this service is build the machine learning models with the data on their own local storage in privacy-preserving manner. Further, it supports to average the machine learning models in different parties into a global model by using federated learning. So we propose blockchain-enabled coordinatorless federated learning system in the Let'sTrace platform. So this is the interaction of different components in the system. You can see that there are blockchain network will be formed between entities and companies. Each blockchain node comes with verification service, which handle with In-ToTo and TAF, and the federated machine learning service. Federated machine learning service implemented with PyTorch and PyShift federated learning libraries. Each node further have their smart contracts on the blockchain node, as well as storage, which stores all the digital identities, supply chain information, and metadata information. There will be peer-to-peer communication between nodes as well. We handle with Apache Kafka. So that's the high-level interaction between different components of the system. Now let's look at the functionality based on the use case. Assume there are some vendor and company and service provider in the system. First, software vendors and companies need to register in the system. So main purpose of service provider is to register the identities of the software vendors and companies. Once register the identity, so they will give access to the web portal. So then they can onboard to the platform, both vendors and companies. In here, the DID or decentralized identities will be created for the vendors and companies and stored on the ledger. Basically, vendors provide the software products. Vendors first need to register their software products in the Let'sTrace platform. The product information also can stored on the blockchain ledger. So then companies can purchase these software products from the vendors. When purchasing, agreement will be formed between the vendor and the company. So agreement terms will be defined, the various notification functions, as I have mentioned previously. To officially onboard the product into a company, the agreement need to be accepted by the software vendor. Once the agreement is accepted, the product will be officially onboarded to the company. Now product is onboarded. Assume in some scenario, sometime a new patch update of the software will be released. Based on the agreement terms, the vendor need to be notified about this patch update and all the verification information to the companies who using this product. In this case, vendor generate a notification about the patch update and send to all the companies. Then once notification comes, so system will fetch the patch update and verify the patch update using TAF framework, and patch update supply chain information will be verified using the In-ToTo framework. If everything is fine, so the package can be used. If there's any vulnerability found, it will be notified to all the parties who are using this software product. Finally, we update the verification state in the ledger about the software update. That's the high-level functionality of the Let'sTrace platform. Let's see how we preventing supply chain attacks with Let'sTrace. Let'sTrace platform is designed to handle the software patch release management and patch integrity verification by using blockchain smart contract. The integrity of the patch associated with the software product is verified by using the TAF framework. We handle the integrity verification via the update framework. Moreover, all the software update information, software packages in the system need to be comply with the In-ToTo protocol. That means all the software release information, build information, kind of information need to embed into the software as a In-ToTo metadata file. That means all the supply chain information of the software update will be embedded into the product as a In-ToTo metadata. Then this patch update can be verified via the In-ToTo framework in the Let'sTrace platform. When releasing a patch by a vendor, the patch need to be thoroughly tested and summary will be uploaded into the Let'sTrace platform as well. Then further this information can be verified in the Let'sTrace platform. These patch updates and patch supply chain information can be viewed and verified by the participating utilities in the Let'sTrace platform. That's a high-level idea. Further, Let'sTrace platform can build machine learning models with the supply chain data in the different peers using federated learning system. In here, the different peers can have their own local storage with supply chain information or supply chain attack information. Then the federated learning system in the Let'sTrace can build machine learning models with the data on the local storage and finally average into the global model by using federated learning system. Once the machine learning models are built, these machine learning models can be integrated into blockchain smart contracts to further verify the supply chain data. If any attacks comes, so it can be real-time detected by using these machine learning models. If any suspicious intrusion associated with the software or patch update is identified in the verification, it can be reported and notified in real time to the utilities and vendors in the Let'sTrace platform. This enables necessary actions to mitigate the vulnerabilities. Now let's look at the implementation details of the Let'sTrace platform. We have built the Let'sTrace platform by using microservices-based architecture. Various functionalities in the system decomposed in the small services or microservices and run as a distributed system. Here are the information. The platform developed with microservice-based architecture. The deployment of the microservices done with Docker, Kubernetes, and Helm charts-based container orchestration system. Peer-to-peer communication of the microservice implemented with reactive stream-based approach. All the microservice communication handled with the Apache Kafka. To implement the blockchain functionalities of the Let'sTrace, we have used Rahasak blockchain. Rahasak is another research work we have done in the blockchain area. With Rahasak, we're trying to integrate blockchain into highly scalable enterprise level application. Rahasak is a highly scalable blockchain for enterprise level application. We mainly target big data, IoT, banking, finance, cloud computing, like enterprise application in the Rahasak. All the ledger functionalities of the Let'sTrace we implemented on top of Rahasak blockchain. Rahasak blockchain comes with functional programming and actor-based concurrent smart contract platform. It supports concurrent transaction execution on the blockchain. All the smart contract functions or ledger functions in the Let'sTrace platform we have implemented on top of Atlas smart contract or Atlas smart actors. So that means we write all the smart contract functions on top of actor-based concurrency handling support on the smart contract. There are various peer-to-peer notification functionalities in the Let'sTrace platform between vendors and companies. To support this notification, we have used Firebase push notification service. For the authentication and authorization, we use JSON Web Token based authentication and authorization service. And I have mentioned that each peer in the system can have their own local storage, which can store all the supply chain information or any attack data information in a privacy preserving manner. We have used Apache Cassandra-based off-chain storage to store all the information. The federated machine learning service, we plug to this storage service, and build the machine learning models with the data on the storage service. So then these machine learning models can further aggregate it into global model by using the coordinated federated learning system on the Let'sTrace. We have used Apache Cassandra as the off-chain storage. To build the federated learning functionalities, we use PyTorch and PySwift federated learning libraries. By using these libraries, we have built coordinated federated learning system on top of Let'sTrace platform. Okay, these are the main implementations. That's it from my side about the Let'sTrace platform details and the implementations and the architecture. If we have any questions, we can discuss them now. Okay, thank you very much for your valuable time.